All right, so we've got the 2015 FRQs, and we're starting off with a table with a velocity function. Now, things to know is that Part B and Part D are not assessed this year on the AP exam, but we'll go over them anyways. So let's see here, use the data in the table to estimate V prime of 16. So this is a popular one you've seen. We can say V prime of 16 is approximately all right, and essentially we can estimate a derivative by looking at the average range or average rate of change between. The velocity at time 20 is 240 minus at 12, which is 200, all over, that's essentially 8. So we have 40 over 8, which is 5, right? Now we just need to estimate V prime of 16, but notice that we have units here, so we can say prime of 16 is approximately 5, and remember we just derived velocity, so what is velocity measured in? Meters per minute, in other words, dv over dt. If we derive that again, we're really estimating d squared v over dt squared. So this would be 5 meters per minute squared, or you could say per minute is sometimes how you'll see it. Right, in other words, you're estimating dv over d squared v over dt squared. Important to know that. Okay, now we're going to get to part B. Again, this is not assessed. Well, the Riemann sum kind of is, but the absolute value integral expression is not. So what we're going to do is we're going to say, now we didn't really get quite to this in class doing it quite like this, but if you're going to estimate the absolute value, and we're going to do a right Riemann sum, then essentially what we have here is we have, well, let's do a right Riemann sum. Our right Riemann sum is going to start with your function value that is at the right, or actually, I'm going to do it like this. A right Riemann sum with 4 subintervals in the table just means you're not starting at 0. So you could think about it as starting at 12 and moving up, but I'm going to think about it as starting from 40 and moving downwards. That way I'm getting these step lengths right. So I'm going to have v of 40 times how far it travels till the next point, which is 16 units, plus v of 24 times how long I carry that for, which is only 4 units, plus v of 20, that takes me 8 units until I get to 12, plus v of 12, and I carry that for 12 units until I get to 0. Now the thing is, we wanted the absolute value of this, so how does the absolute value play into this side? You're just absolute valuing every value that you get in here. So we didn't ever cover this, it's not covered this year, don't worry about it, but really what this means is we have 150 times 16, and this isn't even a calculator question. We have positive 220 times 4. We have positive 240 times 8, and we have positive 200 times 12. This is awful. Can't believe this is not a calculator question. I mean, it's not too bad, but I really just don't feel like it. Okay, well, let's do this. I'm going to try to not use a calculator. Am I? Let's see here. So that's going to be 1,500 plus 900, which will be 2,400. Then we have that would just be 880, right? 24 times 8. Well, what's 12 times 8? 96, so double 96. I think would be 192. So 1920. And then that would just be 2,400. And goodness. Okay, it's going to make a nice 100. So we have 2,800 with 4,800, which means we have 7,600. Let's just see. Yay. Okay, so we have 7,600, and yeah, indicate the units of measure. Well, if we're integrating velocity, in other words, if we're finding area by multiplying these minutes by meters per minute, well, then the minutes are canceling out, and we're just measuring meters. Again, integrating in context is not on this year's AP exam. Integrating absolute values of velocities and things like that is also not, but we did it. Okay, part C, back to something that is in the AP exam. So they give us Bob, who's riding his bike with a velocity measured by that function, and they want to know his acceleration. And so if we have Bob's velocity, then we're really trying to find b prime of t, which is going to be 3t squared minus 12t, and that's it, because the 300 is a constant, it derives to 0. And now we want b prime of 5, 25, 75, minus 60. So we get 15, and again, that would be 15, just say meters per minute squared. All right, and again, they didn't say indicate units, but you might want to anyways. Okay. Now also, oh, I guess I didn't answer this in part B. See, make sure you go back and read things. They want to explain the meaning. Now again, this is not this year's exam. This would be the total distance Johanna traveled from, I guess I should say the approximate total distance, t equals 0, t equals 40, or in 40 minutes. Okay, so it's how far she traveled in total. So in other words, at some point, because this is negative, she backtracked somewhere, somehow, but we're still counting the backtrack, right? So in other words, this is what we call total distance. If the absolute value wasn't there, it'd be what we call displacement. Again, none of those concepts are in this year's AP exam. Okay, last but not least, on part D, what is the average velocity during the interval? Again, average value of a function or average something, except for average rate of change. That is in the exam, that's just slope. But average velocity is not going to be on the exam either, but we can still find it. How do we find it? Well, if you want to find the average velocity for a certain time interval, it's 1 divided by the amount you're changing in the interval. So from 10 to 0, 10 minus 0 is 10. Integrate velocity. So if you want the average of a type of function, you have to integrate that function and then divide it by the bounds of the interval, or the net change in the bounds of the interval. Okay, So that's going to give us 1 over 10 times t to the 4th over 4 minus 2t cubed plus 300t, and we're evaluating this from 10 to 0, which is good because all these have a t, so that whole 0 term is going to go away. So we really just have 1 over 10 times 10 to the 4th over 4 minus 2 times 10 cubed plus 300 times 10, and I'll just put a minus 0 to indicate that I understood that when I plugged in 0 it goes away. Okay, I'm going to do one little trick here. If this is 1/10, then all these powers of 10 can be reduced by 1. So this is really 10 cubed over 4, which is 1,000 over 4. If we're going to divide 1,000 into 4 pieces, that's 250 each. And then now we have negative 2 times 100, or 10 squared, because it's going to cancel out, so that's negative 200 plus negative 200. And then we just have plus 300. So we end up with, what is that, 50? So 350 meters per minute is the average velocity from t equals 0 to t equals 10. Okay, and let's just check everything on the scoring guideline. Let's see if we got this right. So now again, I'm putting in the units here. Usually on all the more recent AP exams, they've always said indicate units of measure, but you might just want to do that yourself. Again, I said meters per minute, or you could say meters over minute squared, same thing. But one thing that's true is make sure you include that this is an approximation. All right, up next. So again, we can see they did theirs from least to greatest x values. To me, if I'm doing a right Riemann sum, it just makes sense for me to start on the right and carry it back to the left. Same answer either way. We get 15. We did 15 meters per minute squared. And I used v prime of t. Then I have an integral, I have the antiderivative correct, and I have my answer. So there we go. Notice they didn't really go through the extra step of noticing how to use the 10. But again, the only things you should have been concerned with on this is part A and part C. So if you got those right and B and D were incorrect, hooray, you just reviewed a little bit of Calc 2, but it doesn't matter on this year's AP exam. So just make sure you understood A and C.